Alright, hi guys. I wanted to go over, it's been a while, feels like it's been a while, how to solve related rates problems. So, hopefully you have these notes in your notebook, but I've written them here again. So, solving a related rates problem. The first thing you want to do is draw a picture. Now, if you don't know what kind of picture to draw, then, read the problem again. Usually there's a hint in what they are describing or the adjective that they're using that tells you what kind of shape you should be drawing. Second thing you want to do is you want to write an equation. Now, when you're writing an equation, obviously if you know what the picture looks like, then that'll give you a hint about what the equation should be. Third thing you want to do is write down the information that you're given and what you have to find. Now, depending on the problem, it's easy to figure out number 3 without even writing the equation, but you do have to do both. So make sure that you're not skipping a step, even if you're doing them in a different order. That also means don't skip step number 1. By the way, I'm going to add something right here that I also want you to add in your notes. Please label, right? And we'll talk a little bit more about what you should be labeling in your notes, but it is important to label your picture because that's going to help you solve the problem. Now, right here, I've added that extra writing equation 2. Don't worry about this for now, right? The problems that we're solving today and at least before break, we don't need equation number 2, so don't worry about that for now, but we will be getting into those kind of problems soon. Then we take the derivative with respect to time. It's not always with respect to time, but it's 99% with respect to time, so that's why I've written it here. We are doing related rates problems, which means that we're dealing with speed, usually. Like how fast something is happening, how slow something is happening, and all of those usually have to do with time, and so that's why we're taking the derivative with respect to time. Then we want to substitute the given information, solve for what you have to find, and again, write down the final answer in a complete sentence with units. This is really, really important because sometimes when you write an answer in words, it doesn't look exactly the same as you think it would look with numbers. So I'll explain more about that in a second. So, as you can see on the bottom of your paper, I've included geometric formulas. I will give you these formulas for every test and quiz. You don't have to memorize them, but it's a really good idea for you to know these formulas. So, whenever we're solving problems, start getting into the habit of, alright, square or rectangle or sphere, like, you're not looking at each shape. Was that it? Was this it? Was this it? You already know. Oh, that's a sphere. That's the formula. Just wanted to check, right? Not to look for it, but I just wanted to check that that's what it was because I already know it in my head. That's the best way to use formula sheets. But again, I will give it to you, so don't stress out about it, right? It's not a geometry class. Don't tell Mrs. Chan. All right, so first things first, our first example is a thin circular disc changes size, but not shape, when heated. The disc is being heated so that its radius is increasing at a rate of 0.03 millimeters per second. How fast is the area of the disc changing when its radius is 200 millimeters? So I am going to cheat a little bit and not cheat, but I actually have, I don't know if you can see it, maybe I'll put it here a little bit. I have the instructions right here, right? The steps for solving a related rates problem. And I know that my first step is to draw a picture. Let's fold that so you can see that, right? My first step is to draw a picture. So I'm thinking, what kind of picture do I draw? Now, if you know what a disc is, then that already helps you because that kind of tells you what the shape should be. But another hint is right next to that word, right? Circular. That's an adjective describing something that looks like a circle. So I'm going to draw a circle. Ta-da! All right. What's my second step here? right? Oh, and I was supposed to label. Sorry, this is a different sheet. But let's actually maybe wait until I get to the given to think about this, because I'm looking at this, right? The radius, oh, hold on. I can label the radius. The radius is increasing at a rate. Okay. I don't know. One thing different I'm going to start doing this time is we're only going to label the things on the picture that don't change, right? And all of these numbers are changing, so I'm not going to label anything yet. So step 2, write an equation. Okay, so the hint is it's a circle, but I have 2 equations for a circle. I have the area and the circumference. But it's saying how fast is the area of the disk changing. Okay, so I'm going to write a formula for the area. Okay, then next thing I want to do, given and find information. So I'm going to do that under my picture. Given, find. So I know that the radius is increasing at a rate of 0.03 millimeters per second. The radius is increasing at a rate, oh, if I see rate, I know it's something over dt. And if it says radius, I know that that's dr over dt. So I have dr over dt equals 0.03 millimeters per second. Did not think about this, okay? Okay, what do I want to find? Now, I know I haven't written the 200 yet, but hold on. So I want to find out how fast, how fast. So that's also speed. So I know I also want to find something over dt. How fast is the area? So that's dA over dt. Oh, I want to find dA over dt. Okay. When? Oh, so I'm going to write this right here, because we know that the area, the speed that the area changes depending on how big the circle is. So I want to know how fast the area is changing when R is 200 millimeters. Not any other time, just that. So actually this and this are really closely related, these two information. So I'm going to put this with the find. And I know this is a little bit different from how we did it in class before. So that's why I am clarifying it now. So this, okay. So what is my step 4? I want to take the derivative with respect to time. Cool. So I'm going to go up here. d over dt. I know pi is just a number. So I'm just going to move that 2 in the front. So 2 pi r. And I'm going to use the chain rule to get dr over dt. Then I'm done. Then I want to substitute the given information. Okay. So, given information that is, given information. That's dr. That's this. 0.03. And I also know that radius is 200 millimeters, right? Okay. So that is, and I'm going to use my calculator that I cannot find. Wait, hold on, I have my cell phone. Let's do it. All right. So I've got 2 times pi times 200 times 0.03 equals 37 point, I want 2 decimal digits, but that's a 9, so it's going to be 70. Okay. When you do these problems, it's okay to have decimal answers. But make sure you have it to 2 decimal digits, and make sure that you're rounding at the very end, not in the middle. Okay, so that's my answer. Almost done. Oh, wait, I already solved for what I had to find. Yes, okay. Then the last thing is write down the final answer in a complete sentence with units. Okay, so how fast is the area of the disk changing? Oh, so the area of the disk is changing at a rate of 37.70 millimeters per second. Huh. Alright. I think I'm good, right? Now, when you get to this point, this is when you say, wait a minute, did I forget something? Did I make a mistake? Let's just look it over. Now, the biggest thing that is going to be a mistake is going to be units. So, is there anything that I could be doing better here? And yes, right? Because we're looking at area. Hey, the area of the unit, oh, the unit of area should be millimeters squared. So, make sure that when you're doing this, your unit and what you're looking for matches. And in fact, one thing that I should probably add here, and I'll add for my notes for next time, is that this should be, oops, millimeters per second, right? Let's write that next to what we have to find so that we don't make this kind of mistake later. Okay, and that's it for now. Bye, guys.